Okay, so at the top, you write down test, check, list. And we're going to start with accuracy. On page 100, Laura. Accuracy. I will ask you on the test at some point, how do you know something will be accurate? And so we want a standard unit, and we're looking for the scale. That has to be an appropriate scale. Like you can't use a teaspoon to measure the amount of water in a bathtub. It's too much water for that unit. Okay. So standard unit, okay. Another way of looking at it in terms of definition, it's how close the measurement is to the target. That's another bubble. How close the measurement is to the target. Because of the standard scale, standard unit and standard scale, I will go off to the side here. Okay, should be able to repeat it. So if I measure the soccer field and it's 94 meters, I should be able to tell one of you, here's the measuring tape, go measure it. You should be very close to it. Okay, so that's why we want these two items to be there. I'm going to go arrow off to the side, but I'm first going to write to make sure I have enough room. Accuracy can be affected by, there are two things that will affect your accuracy when you're measuring, or could affect, is damaged device. So if your ruler is all bent up, or also improper use. So you're not using the equipment like the way it's supposed to be, right? Then it will affect your accuracy. Okay, so that's that. And then I'm kind of going to block this off. That's accuracy. That's the section we give accuracy, and then we're going to go with precision. Precision, as a definition, is the limitation of measuring device. I don't know if you remember the scale that I brought, right? It could be pretty precise, but at some point, it has to round. So I will go arrow up and just say that precision is really the limitation of my measuring device. On the side here, I will say that smaller increments will equal a greater precision. And I will, at this point, I can go up a bit, right? I will give you a very basic example. Just make a short ruler. And let's say it goes up by 2. So 2, 4, 6. And let's have the same ruler next to it, also 2, 4, 6. But watch what I'm going to do to the one on the right. I'm going to add the factory, the manufacturer of that measuring device is going to put a mark in between two numbers. Immediately, because of that, this has a precision of 2. This has a precision of 1, right? Because it goes up by 1. Therefore, this is more precise. So I will box this whole thing in. It's kind of like a standalone concept. But you can go off of precision and point to it. Off on this side here, I will tell you that there's 3 ways to get precision. You can get it out of a picture or image. You can get it out of words. And you want to look for markings. And last but not least, a number. So for example, 3.721, let's do 4. 724 grams. The precision is given to us by the last, right? The precision is there. It's the last digit that tells us the precision that this device had, whichever one was used, right? We're gonna kind of circle around all of this. This is a concept on its own, right? So precision also points to that. And now we're going to do uncertainty. I might steal a little bit of space here, so I'm not going to do the line. Uncertainty. It's the margin of error. Caused by limitation of measuring device. It says margin of error, comma, caused by limitation of measuring device. So uncertainty points to that in terms of definition. We're on page 100, Alora. Oh, thank you. I will say this here. Greater precision equals smaller uncertainty. And think about it this way. The more precise you are, like the more of if your measuring device is really precise, like more decimals added, let's say, your uncertainty is so small that at some point it's almost negligible. Okay. I will also give you a formula here. Uncertainty is half of the precision. I think all of you know that already, but uncertainty is half the precision. You also need to worry about combined uncertainty always add all uncertainties. They may or may not be the same, but you always add all uncertainties. Quick example. I'm going to zoom into this example because the numbers are getting rather small. So let's say you were supposed to add these packages and their weights. They each have a precision and they have an uncertainty. So if you're supposed to do this all in one shot, I would just put the precision on the uncertainty like this. Obviously, we don't care about the precision when we add. So if you add all of this up, you get 8.37 kilograms. Plus or minus, I'm ignoring the precision. I just add all of this up, 0.555. It's not always going to be this number. I know we just had it in our AC, right? And what this is saying, it's giving you the measurement plus or minus uncertainty. That is combined uncertainty, right? So if you want to and I will close this whole thing, put this all in one bag here. And last but not least, tolerance. Tolerance definition is range of acceptable values mathematically. To calculate it, we just take the max, subtract the min, I will say that from this, I just need you to remember nominal is the target. It's a bit blurry, right? Nominal is the target. And here I'm going to give you one last time 4 ways to state it's max over min. I'm going to box that in so you know that that's one way of stating it. There's max plus 0 minus the tolerance. There's min minus 0 plus the tolerance. And the last one is nominal plus or minus 1/2 tolerance. You should always be able to, from all 4, write down min, max, tolerance, and nominal. And once you have those extracted, you can always rewrite it in any format you would like. I will put this maybe all in one bag. Looks like a stocking. Look. There. That's the gifts from Santa for you right there. Not the best gifts, are they? I agree. So I'm going to give you that AC. I'm going to get you to keep it as well. I'm just going to treat it as test review. I will post the key online to this one. So if you want to work through your study sheet, if you want to do this, I'd strongly encourage you to review tolerance because it's going to be on the test. And tomorrow, bring your exam booklets, the green ones, because once you're done the test, I want you to work through those, okay?